Hello and welcome to another video. In this video we're going to be working on minimum number of k consecutive bit flips. And in this one you're given a binary array nums and an integer k, and you have a k bit flip, which is choosing a subarray of length k and flipping every bit. And you want to return the minimum number of bit flips required, so there's no 0 in the array. If not possible, return -1. And a subarray is a contiguous part of the array. So in this one, k is 1, so you can just flip one bit at a time, so you can just flip the 0s to 1s and you'll have 2 flips. In the second one, k is 2, so you can flip 2 at a time and there's no solution here. And in the third one, k is 3, so what you can do is you can flip these first 3, so these will become 1, 1, 1. Then you flip over here, so this becomes 1, 0, 0, and then you flip this guy again and you get 1, 1, 1. And they show that here. So the main idea for this problem is there's a couple parts. And this is also 10 to the 5th, so you need like an O of n or n log n. So let's say we have this example, and let's say k equals 3 or 4 or something. Let's just say 3. So the first thing you have to recognize is the optimal way to do this, and you can figure out reasonably simply. I think this was actually in this LeetCode contest, very similar, except in the LeetCode contest, if you flip one number, everything after it gets flipped. But basically, what you don't want to do is you don't want to flip the same segment twice. So like if you flip this twice, it'll just revert to the old state. Also, the flip order doesn't matter. So like here, you can do all these backwards and it will work as well. So like if we flip 5, 6, and 7, we'll get 0, 0, 1, I think. Will we get that? Let's see. Actually, the order might possibly matter, but I don't think it should. Let's see. Oh, right. Yeah. So I think you do get 0, 0, 1. I don't think it'll matter. Okay. Now we do the middle one, 4, 5, 6. So that's this guy over here. So this becomes 0, 1, 1, I think. Or is that 4, 5, 6? Actually, I think that's wrong. So 4, 5, 6 is actually this guy. So this will be 1, 1, 1. I think. Yeah, and then, yeah. Okay, so what happens is this will be 1, 1, 1. And then you could do 0, 1, 2, and that will be like this. So any order you flip these, like as long as you actually do these operations, you'll get the same thing no matter what. So those are the two things you need to realize is A, when I get to a number, I can just, or I guess, yeah, the things you need to realize is A, you don't want to do the same, you don't want to pick the same subarray twice because you just revert. And the order of flips doesn't matter. So if the order of flips doesn't matter, I can just say, whenever I get to a 0, let me just flip that to a 1 and let me take that subarray. So for example, in here, you're just going to say like, okay, so what I want to do here is just take this, flip it all to 1s, because you'll take a segment of 3. So that's like one operation. Then we keep going until we hit another 0, and we want to do a flip here. So we get 1, 0, 0. It's 2 operations. Then we keep going. And then we do another one, so 1, 1, 1. And then you keep going and you hit a 0 here and there's no solution. Because you can't flip this 0 without, like there's also no room. So like I said, the ideal thing is just when you get to a number, flip that and numbers after it. But because we have to flip 3 at a time, there's no way to flip this with changing other stuff. So this would be a no solution. So if this was all, let's just change this number back to a 1, now this should give you a solution. But that's basically what you want to be doing is you just, anytime you get to a 0, you just flip that whole segment starting with that number, and then you go to the next 0, and that way you keep moving forward, so the chunks you're flipping is never going to be the same, right? You're just flipping a k chunk, so like you'll flip this chunk, you'll go to another 0, which will be over here, you'll flip this chunk, and so on. So that's kind of like the optimal way to do this thing. And like I said, you can pretty easily figure that out, just like, how do I flip this 0 to flip this 0? I have to flip this chunk. So if I know I have to flip this chunk, what chunk do I have to flip? You know, like what other one do I have to flip, and so on, and so on, and so on. And then you basically just figure out it's like a greedy anytime you get to a 0, do a flip. So now the problem is, let's say k is like the length of the array. You can't actually flip everything because like if we get to here, we can't just flip the whole array, and then we get to here and we flip the whole array, and we, because that will give you an n² solution. But instead what we want to do is when we do a flip, we want to kind of record what chunk got flipped. And then for every number, all we have to do is figure out like how many times did that number get flipped already, and then we can calculate like the current value of the number. So for example, let's say a flip flips the whole array. When we flip here, we're going to flip this whole array, and we're going to say, okay, this was flipped. This whole thing was flipped. Now when we go to this number, it's a 0, but it was flipped, so it's actually a 1, so we don't need to do anything. Then it's a 0, and it's actually a 1, so we don't need to do anything. Now here it's a 1, but it's actually a 0 because we did a flip. So then we're going to need to flip this whole thing again. Now let's say just assuming like when you flip the number, instead of getting k equals 3, everything from the number onward flips. So then this would flip, and then here you come over here and you say like, okay, this is a 0, but there's 2 flips that actually affected this number. So that means it's actually still a 0, right? Because 2 flips. So I need to do another flip. And then you'll have like another flip, and so on and so on and so on. So basically, once you get to a number, it's possible that you already did like a bunch of flips. And so what you need to do efficiently is record the number of flips you did on the number once you get to it, and then figure out what that number is, and do I need to do another one? And the way to do this, because we have this k equals 3, there's 2 ways. There's in place, but you have to modify input, and there's using a deck. So I'll talk about using the deck. So let's walk through this using a deck. And basically the idea of a deck is anytime we do a flip, we're going to write down the index of the last number that, you can do this kind of a few ways, but the way we're going to do it is we're going to write down the index of the last number that was in that flip. And then as we progress, we're going to be getting rid of numbers that are no longer in range. And then we can just say like, okay, all our flips will be in our deck. So the length of the deck will be how many flips we have done on the current number. So let's walk through how that's going to go. So first we're going to say, okay, we have a 0. We want to make this a 1. So we have to do a flip here. So our result will equal 1 because we have to do a flip here. So we're just going to flip. Now, what's the last number this chunk works on? So the last number this works on is a 2. So we're just going to write down 2 here as the last number that was flipped in this flip. Then we're going to go to the next number. And we don't actually need to flip it. We can just know like it was flipped, but we don't actually need to modify it. So this is basically like turns into a 1. But we don't need to actually do that. Okay, so here we have a 0, and then we check, is this number still in range of where we're at, right? So this is the last number that was included in the flip, and this is still in range, right? Because we're at 1, and the last number is a 2, so it's still in range. So the number of flips we have done here, we can call this like the flips deck or something. The number of flips we have done on this number is the length of the deck. So we did 1 flip. So even though it's a 0, it's really a 1, so we don't need to do anything. Then we go to the next number and we say, okay, is this still in range? Yes, it is. It's a 2 and it's a 2. So it's a 0, but we've done 1 flip, so it's really a 1. So we don't need to do anything. Now here we check, is this in range? It's no longer in range. So now this gets removed, right? Because this was this flip here. So that end point is no longer in range now. Then we check, is it a 1? Yes, it's a 1, and there's no flips, so we don't need to do anything. Now here, there's no more deck, so we don't need to remove anything, but it's a 0, and we have no more flips, so we do need to do a flip here. So we do a flip here, which will be this segment here, because k equals 3 in this case. So the last number in this chunk is 6. So we're just going to write down 6 is going to be the last number. And then we add 1 to the result. Then we go to the next number and we check, is 6 in range? Yes, it is. Now this is a 1, but there's 1 flip, so it's really a 0. So we need to do a flip again. So we're going to say result is 3. And the flip section we're going to do is this section here. So that ends at 7. Right? Because there it's a 1, but we had 1 flip, so it got flipped to a 0 because we flipped this chunk earlier. And now we flip basically this chunk, and that will give us back to a 1. So we keep going. And we say, okay, is 6 in range? Yes, it is. Okay, this is a 1 with 2 flips. So 2 flips just means it stays a 1, right? Because every 2 flips, it goes back to what it was before. Okay, so if it's a 1, we don't need to do anything. We're done. Now here, is this out of range? Yes, it is. So this is out of range. This moves over here. This in range? Yes, it is. So this is a 0 with 1 flip, so it's really a 1, so we don't need to do anything. Now, is this out of range? Yes, it is. But it's already a 1, so we don't have to do anything. We don't have to do anything here. Now, you will get to a case where you will get to numbers, like, for example, let's say this was a 0. So in this case, the result would be 3, but let's say this was a 0. So we can't actually flip, like if we need to flip this number, but we don't have k left, then we have no solution. So when we get to numbers and there isn't a k segment left and it's a 0, we can just return -1 because there's no way to do this. Because like if we were to do this thing, we'd basically flip here. So this is like one flip. Then we'd come over here and we'd say we need another flip here. So 1, 0, 0. Then we need another flip here. 1, 0, 1. And then we need another flip here, but we can't flip this number without turning other stuff into zeros. So we have no solution. But if this was a 1, then we'd have a solution. So hopefully that makes sense. So we're just going to use a deck to keep track of the last index of the current flip, and then we're going to get rid of things that are out of range, and then we're just going to calculate how many flips we did with the length of the deck. So let's do that. Okay. So the first thing we're going to need to do is make a deck. So we're just going to make like an array deck flips. And it's going to be integer flips equals new array deck. Then we're going to make a result. And that's all we need, I think. Then we're going to loop through all our numbers. So for int I equals 0, I is less than num's length. So first we figure out like what the current number actually first we figure out if the first number in the deck is out of range. So we can say if flips is empty. So if it's not empty and flips get first is less than our current index, then we need to pop it. So flips dot, I think it's like remove first or something. Okay. Then we need to get what our current number is. So int current number will be nums I plus the length of flips mod 2, right? Because it just alternates. Yeah, I think this is size. So for example, if we have a 1 but we did 2 flips, we'll get 3 here, and then we'll get a 1. If we have a 0 and we did 2 flips, we'll get a 0, and so on. So this will give you our current number, and then if current is a 0, then we need to do something here. So if we don't have enough numbers to do a flip, right, like if we're on some n segment where we don't have k numbers left, we can just return -1. So we can say like if I is greater than nums, I believe this is nums length minus k, I think. So let's think about it for a second. So here, if this number is at index 2, we can't do it. So this will basically be length is 3, k is 2. So at index 1 it'll work, at index 2 it won't. So yeah, I think it's that nums length minus k. Then we can't, like we don't have enough left to flip, so we can just return -1. Otherwise, if we do have enough left to flip, what we're going to need to do is we're going to need to increment result, and we're going to need to write down the last number that was in our flip. So flips add, and the last number that was in our flip is, once again, let's say we flip this 0 number, and we are flipping 2 numbers, so we'll flip 0 and 1. So the last number is 1. So it's just going to be the current index plus k minus 1, right? If k was 3, we would have 0, 1, 2, so the last number would be 2. So this is just going to be I plus k minus 1. And then we can return result. And yeah, you can basically do this the same way by modifying numbers. So I think there's a solution where you change numbers to like negative numbers and then change them back. Like that works fine too, but in a lot of questions you can't modify numbers. And it'll basically work the same way as a deck. You just modify numbers and then you keep track of a variable of like how many numbers you modified, and every time you get to a number that you made negative or something, then you know like that number is out of range and you just decrease that variable instead. It would work similarly. Okay, and I think, yeah, this is good. And yeah, as far as runtime, like I said, I think something without a deck will be faster, but that's not super concerning, so whatever. Because yeah, you would have to modify input, I believe. So in this case, this is oven runtime and oven space. And yeah, this is very similar to the last LeetCode contest that I did the videos for yesterday, where it's literally very similar stuff, like except for instead of flipping a chunk, you're just, anytime you flip a number, you're flipping every number. The way it worked was like, if you flip this number, you flip the whole thing left. If you flip this number, you flip the whole thing left, and so on and so on. And you basically recognize the optimal solution is just anytime you get to a 0, flip it. So like a greedy solution. So hopefully this is helpful. If it was, please like the video and subscribe to the channel, and I'll see you in the next one. Thanks for watching.